Welcome back to DeepVisus, where vision meets depth. I'm your host, and today we're diving into chapters 13 and 14 of Stephen Grossberg's Conscious Mind, Resonant Brain. This episode is titled From Knowing to Feeling: How Emotion Meets Cognition in the Brain. We'll explore how our brains weave knowledge and emotion together to create feelings, motivation, attention, and intelligent behavior. Our guiding question is: how does the brain integrate cognitive understanding with emotional feeling to guide motivated, goal-directed action? Let's start with Chapter 13, which introduces the CogEM macro circuit. CogEM stands for Cognitive Emotional Circuit, a network involving the temporal cortex, amygdala, orbitofrontal cortex, and hypothalamus. Here's how it works. Object categories from the temporal lobe combine with value or drive categories from the amygdala. These signals converge in the orbitofrontal cortex, where object value associations help shape motivation and emotional feeling. Homeostatic signals from the hypothalamus feed into this circuit, creating powerful feedback loops called cognitive emotional resonances that underpin conscious feelings and motivated attention. Next, reinforcement learning shapes behavior through two key processes. First, conditioned reinforcer learning enables previously neutral cues to trigger arousal and drive behavior. Second, incentive motivational learning, mediated by the orbitofrontal cortex, integrates object and value signals to decide what's worth pursuing. These learning mechanisms explain how we attend to what matters while filtering out distractions, a process called attentional blocking. A fascinating part of CogEM is its gated dipole circuits, which produce dynamic emotional responses like fear, relief, frustration, and behavioral contrast. These circuits can generate an overshoot and rebound effect, explaining why sudden loss or gain of reward resets attention and learning. Such mechanisms also have clinical implications, shedding light on conditions like autism, schizophrenia, and ADHD, all of which involve disruptions in arousal regulation. Moving to Chapter 14, we enter the realm of the prefrontal cortex, the brain's executive center. Here, Grossberg presents the part macro circuit, predictive adaptive resonance theory, which integrates the orbitofrontal cortex, OFC, ventrolateral prefrontal cortex, VLPFC, and dorsolateral prefrontal cortex, DLPFC, with working memory and sensory motor areas. The OFC tracks desirability, how much we want an outcome, while the VLPFC updates availability, assessing whether that outcome is actually attainable given the current situation. The DLPFC solves the credit assignment problem by linking specific choices to their consequences, essential for learning from experience. This prefrontal network supports feature-based attention and planning. The brain primes sensory regions to focus on expected features and switches strategies when novelty arises. Emotional and cognitive signals converge here, guiding goal-directed plans stored in working memory as sequential list chunks. So, to answer our question, the brain integrates knowing and feeling by using interconnected circuits that combine object recognition, value assessment, and working memory. Cognitive emotional resonances in CogEM generate conscious feelings and motivation, while the part macro circuit in prefrontal cortex refines decision-making, credit assignment, and adaptive attention. Together, these systems enable intelligent, motivated behavior. Thanks for joining this exploration of chapters 13 and 14 of Conscious Mind, Resonant Brain on DeepVisus. Next episode, we'll delve into how the brain stores and retrieves memories and how attention sculpts our conscious world. Stay curious and keep following where vision meets